Hey Math 1, this is Mr. Roberts at Shasta High School. I'm going to go through a quick look at the Chapter 3 test. This is just available as an option if you're, wondering what you did wrong, what you could do better next time. We're going to fly through these questions. The first question here involved taking a look at a data set and determining the line of best fit. So we're doing a linear regression here. Um, and I went ahead and I fired up the calculator here and I plugged in the values. You can see we've got a 4, 4, 10, 3, 9, 11. And then I've got 5, 3, 8, 2, 6, and 7. And now that those are in there, I'm going to verify that my stat plot is turned on. It's not. So I'm going to go to stat plot, turn on. And with the statistics plot turned on, I'm also going to ask my calculator to zoom the data or zoom statistics. So choice 9, zoom stat. And there's the points. I can go through here and real carefully plot those points on the Cartesian coordinate plane. So I went ahead and paused the video real quickly while I set up this graph. But you can see over here I've went ahead and plotted 4 with 5, 4 and 3, 10 and 8, 3 with 2, x is 9, y was 6, and the last point I need to plot is when x is equal to 11, we're going up to 5, 6, and 7. So these are the points that I've got on the table here, and you can see they match very nicely with the points that showed up in our calculator when we did our stats plot. So at this point, we're ready to go ahead and do our linear regression. So again, I hit statistics. Remember, when I'm entering the data, I go to edit, but in order to calculate things, we're going to go stats, calc. Looking at this data, it looks reasonable that perhaps a line would go through it. So I'm going to go ahead and do the linear regression, option number 4, and enter again. And you can see it gives me the following values. So let's zoom this out and get some of these written down here. First thing I want you to notice is it does say to round this to the nearest hundredth. And our equation will be y equals, I'm going to write it in function notation, but it's the same, right? Instead of y equals, I write f of x. And then I've got here a, which is if I'm rounding to the nearest hundredth, 0.59. So 0.59x. And then to that, I'm going to be adding, rounding to the nearest hundredth, 1.12. Yeah, it doesn't quite make it to the 3, so plus 1.12. The correlation coefficient we can see on the screen here, if I'm rounding to the nearest hundredth, R is 0.91. So you can see it's a very small data set, but strong correlation coefficient with it there. Next thing, I've got two questions here where I'm asked to, let me zoom in for those. It says identify the functional value when x is 4 and also when x is equal to 12.5. So I'm going to go ahead and plug those values in, right? So when f is 4, this function becomes 0.59 times the 4 that I'm passing into it, and then I'm going to add to that 1.12. And I guess I need to do that on this calculator. So 0.59 times 1.12. Whoops. I thought that might happen. 1.12. And I didn't multiply it by 4. I'm sorry. 0.59 times 4 plus 1.12. That looks better. This looks exactly like what I've written down here. 0.59 times 4 plus 1.12. And I get 3.48. So to the nearest hundredth, I'm getting that this equals 3.48. And then the last thing I've got here is I'm going to do the exact same thing when x is 1.12. So it's going to be 0.59, and I'm going to be passing a 12.5 into the function, and then adding 1.12 to that result. I think I can hit second entry, pull this, second entry? Yeah, pull the last line up, and then I can just come in here I'm going to use the insert function though, so I can type 12 point, I need to overwrite this last one, so 12.5, oops, 5. So I've got 0.59 times 12.5 plus 1.12, press enter. And if I'm rounding that to the nearest, um, geez, rounding that to the nearest hundredth would be 8.50. And the last question that's related to this data set says, find the value of x when the function is 42. So if my functional value, right, and let me just write this right here, the function of x equals 0.59x plus 1.12. What this is saying is if the function is 42, right, I'm not passing at 42, but if it equals 42, in other words, I'm writing the function equals 42 right here. The question is, what's the value of x that produces that? And to answer that question, it's just two quick steps, right? We're going to subtract 1.12 from both sides of this equation, minus 1.12. And after we get that value, we're going to divide by 0.59. I've kind of run out of room here, but we're going to write this anyways. When I subtract the 1.12 from 42, we get 40.88, and that equals 0.59 times x. Let me bring this equation up here, and to help avoid making mistakes, I'm going to rewrite it. So 40.88 equals 0.59x. And final step here, I'm going to divide both sides of this by 0.59, divided by 0.59. So if I bring this calculator over here, I've got the 40.88. And we're going to take that and divide it by 0.59, divided by 0.59. And that gives me 69.2. Let's see, if I'm rounding that to the nearest hundredth, 69.29. So x is approximately 69.29. Now that is the value of x that produces an output of 42. So when x is 69.29 approximately, the function should equal about 42.